Hi, everyone, and welcome to today's webinar. My name is Maryam Hosseini. I'm Solutions Architect at Elucidata, and I'm going to be hosting today's session. My background is in bioinformatics. I've done multiple bioinformatics analysis during my grad life and during my postdoc and other companies at bioinformatics scientists. And over the past 10 years being in the field, I realized that majority of my time and my colleagues' time have been spent on curating and cleaning the data, making it ready for downstream analysis. And that was the point that I came across Elucidata, and I realized that the company's mission is actually providing curated and machine learning ready data sets to accelerate R&D. And that was the time that, I decided to join Elucidata. Elucidata's core product is Poly, which enables people to have curated data sets, as I mentioned, machine learning ready. And at this point, we are not only having all these data and we have the platform, we are also enabling integrating other softwares or pipelines to be integrated with Poly so that it will help with getting more insightful and meaningful information out of the data. And Spotfire is one of those applications, one of those softwares that has a lot of capabilities in generating dashboards, plotting different graphs, or doing some high-level analysis. And because of that, we decided to actually integrate that on Poly. So I'm going to talk more about that today. About the okay, there you go. So about the agenda today. So as I mentioned, I'm going to talk a little bit about Poly just to give you a heads up. I'm not in details, so it's going to be more of just what Poly is. But if you are interested in knowing more about Poly platform and all the product information, please go to our YouTube channel and you can find more in detail demos about it. And after that, I'm gonna show you how we can actually connect Spotfire to Poly and then fetch the data from Poly to Spotfire, do some visualizations and use some algorithms, some functions to actually perform the analysis. Before starting the real talk, I want to just mention that we are recording this webinar, so you can access that on our YouTube channel. And you can also leave your comments. If you have any questions, you can leave it at the chat box and with your name. So I'll make sure to get back to you on that. And if you want, you can also directly email it to me at maryam.hosseini.io. It should be also in the chat box shortly, so you can find those information and ask any questions that you have, and I'll make sure to get back to you ASAP. Okay, so the first thing that I started my talk about was really the problem of curating the data and having the clean data and actually making it ready for downstream analysis. Usually the data in public platforms is generated from different labs and different scientists with different goals and purposes. They've generated this data. And it is not consistent. The file formats are not consistent, and also the metadata fields, they're not consistent. They're not following the same ontology. So in a sense, the data is not fair. It's not findable. And different platforms, they have different GUIs that you have to go on and find the data. And sometimes it's not accessible because of different APIs, restrictions, and so forth. And once you find that, as I mentioned, like the data types are not consistent, and they have different formats, and the metadata fields, sometimes there are gaps in the metadata fields, and also the fields are not consistent across different data sets or data types. So our solution to this at Elucidata is Poly Public Omics Atlas. It is the world's most usable set of public transcriptomics and single-cell data. And all the data, specifically these two main data sets that are our focus for the time being, they get into our platform, and they go through two major steps. First is data engineering, where we make sure that all the data type, they're all in tabular format and they're all consistent. And after that, we perform metadata harmonization, where we use NLP models to fill in those gaps that I mentioned in metadata and make it all columns consistent, all of the columns following the terminology, following all consistent ontology, so that it will be easy to search for the data that are consistent. And after that, it's all in one place, where we call it polypublic omics atlas. And from there, we can really access to all these curated data set, either using a GUI, which is Poly platform, we call it Poly, and also some notebooks in the Poly, which makes it easy to perform analysis. If you want to search for the data through programmatic way, you can actually do that. So after that, we've decided to also integrate other platforms, other softwares to this Poly, so that it will be easy for the user not only find this curated data set, but also do some meaningful analysis on the data. And for that, we already have integrated some other softwares like cell by gene for single cell data, synthesis for transcriptomics data, and so forth. But for today, the focus is going to be a Spotfire. A Spotfire is very extremely powerful in analytics platform, and it helps us to derive valuable insight out of the data, make dashboards, and perform analysis and plot different graphs. This is just an example of the dashboard that we've made for one of our atlases, which I'm going to show you shortly. But basically, Spotfire has been used broadly in different fields, especially business, to really get meaningful insight of the data. And that's why we've decided to actually include that on Poly. On that note, I want to actually stop here and go straight to Poly to show you how we can search for, and what Poly is, and how we can search for the data of interest. So this is the first page on Poly platform. As you can see, we have different omics atlases for different projects and different needs. For today, I'm going to go to GeoMix Atlas, which is an atlas that has all the transcriptomics data from Geo source. And over here, you can see we have about 105K data sets.
A quick, yep. I think you've not navigated to Poly. Could you do that?
Oh, maybe you cannot. Okay, maybe you cannot actually. Let me stop sharing and reshare it again, because I can, yeah. Thanks for letting me know. Okay, I should go back probably. Okay, yeah, thank you very much. This is the first page on Omics Atlas, and you can see we have different Omics Atlases, as I mentioned, and I am gonna go through Geo. And over here at the top, you can see we have 105K data sets from Geo, data type transcriptomics, and you can see top disease and organism distribution in this data set. Clicking on the atlas itself, so each card is representative of one data set. And on the left side, you can see we have filtering options. So as I mentioned, because we've done the curation of the data and metadata, and all the terminologies are consistent, now we can easily search for the data set of interest. So let's begin, just make a search for a data set. For example, say I'm interested in comparing breast neoplasm disease to normal from human data set. So let's just search for that. So disease should be breast neoplasm. Tissue, let's just search for breast. So I'll just choose breast. And we mentioned that we want it to be Homo sapien. Well, other things are going to be the same. And say, let's just, did I also use human? Yes. So let's also say, for example, I want minimum of 140 data set, 140 samples in this data set, so that you can have a sense of also this capability. And let's just restrict it to a smaller number so we don't get a lot of hits. So yeah, we get 7 hits for this search, and we can easily go through each of these data sets and actually choose the data set of interest. Let's just choose one. I'm gonna choose this one. It's a study of breast biopsies. Going to the details of the data set, we can see that there's gonna be a description of the data set over here at the top, and this link would take us to the source of the data set so we can see what the data is about, and or we can see the overall design. Here it says that we have 143 samples from 79 healthy and 46 breast cancer samples. And we can also see some graphs, kind of visualization of the data, say 55% normal samples and 44% breast neoplasm. So you get an idea of how we perform searches on the poly. Again, as I mentioned, this is not a very detailed demo of poly, but just to give you an idea of how we do this. And you can go to the YouTube channel and look into more details, analysis that you could do on poly and also search for the data. But on that note, let's say we found this data set and now we want to fetch that data set onto Spotfire and actually search for the data. Have some dashboards on that data. So I'm gonna probably move to poly Spotfire now. Okay, I am gonna share. Okay, perfect. So actually, let's go to the very beginning. Okay, so here is basically the Spotfire, the visual place, the interface of the Spotfire. On the top, you can see some menu bar that helps you to navigate through different folders and also find some data and so forth. On the left panel, we have different options to fetch data, and for example, to fetch data here, which we can connect either to online AWS or like Google Cloud, or we can actually browse for local files. And also we have capability of visualizing different data through these options. And also we can use different functions to perform some analysis. Here, this page that I've opened is actually the place that you can connect to Poly using an API. And for that, basically, we're just gonna go to Poly again, copy the authentication key, and after that, paste it here. And after that, we can actually fetch any data that we want from Poly over Spotfire. Again, I'm gonna just stop here and share my Poly screen. So over here, if we click on the left, you can see authentication. We can go there and copy this authentication number, and after that, paste it back to a Spotfire. Okay, there you go. Well, I've done it before, but I'll do it again, just go through that with you. So now I've clicked it, and now I already have the API key here on Poly, and after that, it will be super easy to fetch the data sets onto Spotfire. So let's now start doing some visualization of the data. First thing would be fetching the data from Poly to Spotfire, the data set that we found. For that, well, I'm going to use a function that I've written. So we can write as much functions that we want and save it over here. I've saved these two, for example, here for fetching the data set from Geo, Atlas, and also Compute and PCs. But we can write as many functions as we want, and also we can make changes to the function based on our need. For now, let's do fetching the data set. Because I've already mentioned that I've copied the API key here, so I can just say that document property and set the document to API key that I've already had in this page. For dataset ID, I have to write it down because I do not remember. Let's see. Okay, it was GSE 18672-GPL 6848. There you go. Okay. And after that, I click on OK. So these are the inputs that I've already identified as input, the good input for this function. So I have defined those input files. Now, if I say OK, it will fish that data set from Poly to Spotfire. You can see the different categories like column names in the algorithm, because I wanted to have like more simpler version here, simpler version of metadata here. So I've just chosen these 3 columns to be fetched to Spotfire. If we click on visualization, first, let's just look at the table of that information. So this is the table. We have sample IDs. And as I mentioned in the function, I've just added the cell line, disease, and tissue for this specific data set. And for cell line, there was no like cell line information for this data set, so that's why it's none. And after that, we've curated the disease and breast and tissue over here. Let's also plot some other charts for that. For example, a pie chart. So we can easily, Spotfire already identifies where's the best place to put the chart, but we can also move it to the place that we like is better. And yes, so let's actually make sure that so I have different information here. So let's say it's metadata and it's coloring by, okay. It should be able to do that too. Okay, and it's colored by different disease here. So we can see how the data is colored based on different disease. And these are different options that you can also, change based on size and so forth. One other thing would be, say, for example, having bar chart. So I can, if I don't want it to be here, I can just click on it and put it here or at the bottom. Let's see. Okay. Okay. I can do it right. It's more like you have to get used to kind of moving this stuff, but you get the idea that you can move let's see. Okay, yeah, there you go. You can see that now it's good. So it shows how we can also move the information here, the plots here. One thing that, okay, you can see that the coloring also changes based on different parts that we show, for example, because we have the cell line is the same. So when I'm clicking on it, we can see that it's just like showing one exact same thing. Also, the tissue is the same. So it's going to be, only 100% for that tissue. Let's now look at the expression data for this one. We can either, again, fetch the expression data for this data set from the function, or we can add it from the folder. Because I want to show you how we can also fetch the data set from our own file, I'm also going to do that. Let's first rename this one and save the page as fetch data. Okay. Okay, we'll save it there. We'll open another page. I'll move it here. And then let's fetch the data from our local file. So I already have expression file on my computer, so I'm going to just fetch that data. And once I do that, it's going to put the data. And we can visualize the different, rows and make sure that you're comfortable with that. And then fetch the data onto Spotfire. There you go. And this is going to be the name for this file. It's going to take sheet 1 from that file. And okay. And after that, we can also visualize that on a table view to kind of have an idea of what we have. So a column names are sample names, and on the left, row names would be genes. So now that we have these information, so we have metadata information and also we have the gene expressions, we can do multiple different things. For example, let's say we want to calculate PCs for this information. So for that, again, I'm going to use another function, which is compute PCs. I have already written the code, so I'm just going to put in the information. For expression, we already we fetched the expression data, so I'm going to use that information. For the metadata, again, we fetched it using the function getGeo, and we can also write how many top variables we want to calculate. Usually, like it's 500. So, example, if you're using DSeq2, for that one, it's 500. So let's go with 500 for now. And okay, there you go. And now it computed a PCA score table for us. And we can, again, first look at it. So this is the table. Now we have the PCA scores. The row names are samples, and at the top we can see different PCs that have been calculated for this data set. And okay, and we should also see columns on the metadata at the very end, so it's all like aligned with the sample number. Now that we have it, first thing would be a scatter plot to really show different PCs on over here. There you go. And it's already, so Spotfire already kind of decides or thinks that which visualization would be best. For example, coloring, it's already colored based on the disease because it knows that probably that's the best variable. But you can also change it. For example, you can change the color scheme based on different criteria that you would like over here. And you can also change, for example, the shape based on disease. Again, let's change the shape based on disease. So you can see now the breast neoplasm samples, they're in a square and normals are in circles. And hovering over a data set, you can select it, and also you can visualize it over here. So you can see it's already colored on, and you can see what sample it is. And also what we could, and if you click again on the graph, you can see that it will go back to the previous view. And if you want to add more information, for example, here it's not showing the name of the sample. What we could do is hovering over here, and at the left, you can make any changes. For example, the color, already the color scheme is like blue and red. We can change that. Now we wanted to change the label. Let's say we want to have labels based on sample ID. So I've changed it to sample ID. Now, if I click on it, you can see that there is now sample ID over here. So we can make lots of different changes to the graph and get more information out of it. I think this is kind of like overview of how we fish the how we search for the data, and then we move that data onto Spotfire and visualize it and perform some analysis on it. After that, I want to show you some other dashboards that I've made. And it is not just for one data set, but it's for many data sets that we have on the Atlas. We have this GDX Atlas, which is a gene differential expression atlas on Poly, where we have all the meaningful comparisons from Geo. For example, sample disease versus control or drug versus control. So we have put all these comparisons over here on this atlas, and using again one of these functions that I just showed you, I fetched all those information, all those data sets to this atlas. So we have all this information, and we can look at different like disease, like if we are looking for specific comparisons, we can click on that, look at it, and see how many data sets have that comparison, or how many data sets, what disease are involved. For example, let's say I am looking at perturbation of breast neoplasm. There you go. So actually, let's just write breast so that I'll get more disease here. So you can see like all those perturbation that's like any disease related to breast versus control, and we can see the distribution of these perturbations here. And if I click on any of these, for example, triple negative breast cancer, so versus control, I can see the dataset ID that has those information, and I can look into that and go deep into the data set if I want and look at more information of those data sets. Or another option is this disease, and here we can see that there are more curated disease in this set of data sets. So that is one way of really visualizing the data set that are already in Poly. And again, this is kind of possible because we've already done all of these like comparisons. We fetched all the data and curated it. So it's possible to fetch all of them here on the Spotfire and do such cool things about it. One other thing that I wanted to also show you, which is really cool, here we want to look at actually a gene and see how, for example, if I'm given a adjusted ADJ, adjusted p-value, and also log-fold change, which data sets will have that common gene highly expressed or really expressed. So for that, for example, let's say, again, we are comparing neoplasm versus normal. Let's look at those data sets. And now when I'm clicking on that, you can see the data sets that are in that neoplasm versus normal category. And on the right side, you can see how it's showing the fold changes that I've mentioned. So log fold change below 1.5, you can see it here. And also for other data sets, it's above that. So you can see that, and you can look at the adjusted p-values and so forth, and some more information about it. And on the left, we can see, the comparisons that we have and how this gene has been highly expressed in any of these comparisons. So this is really the overview of getting the data onto a Spotfire from Poly, and then exploring that information, that data on Poly, generating dashboards, different plots, playing around with the plots, and getting more insight out of the data. I hope that this was helpful. Thank you very much for joining this session and webinar. And we are really looking forward to see more of people being interested in clean data and curated data, and spending less time on curation and spending more time actually exploring the data and making R&D much faster. Thank you very much. You can find the recording of this webinar shortly on our YouTube channel, and please reach out to me via my email if you have any questions. Thanks. I'm Maryam, and I'm signing off. Thank you.